Hello, my name is Macaulay Gowan and I'm a PhD researcher at the University of Hull's Centre of Excellence for Data Science, Artificial Intelligence and Modelling, otherwise known as DAME. Today I'm joined by Winifred, who's going to be talking to us about her project. Would you care to introduce yourself, Winifred?
Hi, my name is Winifred Njoaguani and I just concluded my research project, which is on the title Explaining Errors in Machine Learning Models.
Fantastic. Yeah. So to start, could you give us a brief overview of your project and its central objectives?
Okay, so my project, like I said, is on explaining errors in models, and the main objective of the project is to determine if machine learning models, if the errors made by machine learning models can be explained using some existing explainable AI tools, in the field of explainable AI. So it's not just about using machine learning models to perform tasks, but when these models make mistakes, can we actually explain the errors made by these models? Yeah.
Fantastic. It's a very important work.
Yeah, very important.
So what specific AI or data science techniques did you use during your project?
During the project. So first of all, we'll start with the model I trained, because obviously we want to explain model errors, we need to train a model. The model I trained is the EfficientNet V7 model, which is a pre-trained basic convolutional neural network, but obviously a deeper one, that can perform better at image classification. Yeah, so I trained this model. It's a pre-trained model, so obviously transfer learning, that's a very important technique I used for the training of this model. So I just basically fine-tuned like the final layer and then adjusted it to meet my data set. That's one model. Another important tool I use, or other tools I use, is the explainable AI tools. In the field of explainable AI, we have several techniques. So I used 5 techniques for this. I used GradCam, which is a very popular explainable AI technique. I used Lime, I used Sharp, and then I also used the new one, not really new, but I used counterfactual conceptual explanations, also known as CCE, because it's quite a mouthful. And then I used saliency heat map. So these are the 5 XAI techniques I used to check the errors made by EfficientNet V7.
Fantastic.
Yeah.
So during your project, what particular challenges did you face and how did you overcome them?
I faced a lot of challenges. I'll start with the data set, which is not a very common challenge in research projects, right? The data set I chose for the project is I started with the Cypher 10 data set, which is a very common classification data set, because it has 10 distinct classes, right? So it just does image classifications beautifully. However, that wasn't the case for my project, right? So the images in the Cypher 10 data set have like very small pixels, 32 by 32. So it was difficult for this model struggled to see those images. And so I had more errors because the model was really struggling with the images. And then after, eventually reducing the number of errors I had, I applied GradCam, for example, on the images, and I got blurry output because the images were quite tiny. So not only did my model struggle with the images, the XAI tools I used also struggled with the images. That's one challenge. And then the second challenge is eventually, I had to do something called mapping, which is a technique, right? I had to basically create a custom data set out of the ImageNet data set. The ImageNet has like 1.3 million images, so I can't use all of that, obviously. So I had to map, create a data set for myself, map the sparse classes into like distinct classes, and I used them. And you would think, wow, that's good, challenge over, right? No. Then another problem is we needed some form of errors, because we're trying to explain the errors made by machine learning models, and the ImageNet dataset is known for having good quality, so not really many errors. So I had to introduce synthetic errors into the dataset by just like twisting just a tiny bit, 2% of my training data. So these are the errors I faced, and this is how I was able to go around. The challenges I faced and how I was able to go around the challenges. Yeah.
Fantastic.
Thank you.
So, given that you've overcome those challenges and you've come out the other side with a successful project, how do you think your project will impact the real world or potential industrial applications?
So, like I said, in the real world, right, first of all, a lot of scientists and researchers just focus on the correct classifications or correct predictions of machine learning models, completely ignoring the fact that machine learning models are not infallible. They make a lot of mistakes. And so in the real world, we have trustworthy and responsible AI systems. We are able to envisage the errors made by the models. We're able to better mitigate these errors. So I'll give you an instance, like in the case of in the healthcare field, right, which is very important. An error is not just an error. It could have very serious consequences, especially because we use them for critical and important purposes. Like we have images, for example, images with different say skin diseases, right? And we need AI models to actually correctly classify these skin diseases so that doctors can give better prescriptions and all of that, right? And so if we have machine learning models that keep making mistakes, we'll have wrong predictions, we'll have wrong prescriptions, and it's just a cycle of errors that keep going on and on. So in the real world, we are able to better explain these errors, know why these mistakes were made, why the model made these errors, and work on the errors. So we have error mitigation, right? We are able to trust AI systems better. And in the in the larger perspective of like responsible AI, we have AI systems that are responsible, that are ethically safe, that we can understand, also very important, that we can interpret, and we know why they made errors, and we can correct errors. So yeah.
Absolutely. It's people's lives that these decisions are based on, and they have a right to an explanation. So how do you see your project, now that it's completed, evolving or shaping your future research directions, or indeed your career going forward?
Okay, so I do have passion for a responsible AI, ethical AI that we can trust, that we can explain, that we know why it came about this decision, right? And so this project further opened my eyes to see that we blindly trust these AI systems, as well as, as much as we've used machine learning models to perform a lot of tasks, and they've been doing well, if I do say so myself, right? We've had a lot of correct predictions, a lot of correct classifications. There's a little shortcoming, especially in the fact that they make errors, and the current research in explainable AI have not really focused on the errors of these models. So we all know that AI models are black boxes. They are popularly known as black boxes because we can use AI models to perform certain tasks, but we can't really explain how they came about, those predictions, for example, because deep learning models, the deeper they get, the harder it is to explain, right? And so the field of XAI has tried to introduce these techniques, like I mentioned earlier, like GradCam, for example, like Sharp, like Lime, to actually explain the predictions of models, but not focusing on the fact that they make errors. So how about we explain the errors in models, so that people, researchers, scientists, people who use AI systems can better trust the models that we are training. So generally, I'm now more interested in explainable AI, in research and explainability. I've been able to uncover, this project has been able to uncover a lot of shortcomings in the field of XAI. For example, the few research that we have that currently use XAI techniques to explain model decisions and model errors, we don't even know how well they did. So there's really no one actually evaluating the effectiveness of these XAI tools, which I did in my project. I used fidelity, sparsity, stability to actually show if these explanations are faithful to the model's decisions, right? So I'm now more interested, I'm now deeply interested in not only churning out machine learning models that work, but machine learning models that are correct and that we can trust. So I'm now very deeply interested in the field of explainable AI at large. I now want to know that we can better trust AI systems, that we have responsible models, that we know why these models came about, their decisions. So it can also be used in like other fields, like for example legal fields like compliance, just generally, I'm now more interested. I want to know more,
Yes.
better in the field of socially responsible
Very
AI.
interesting.
Yeah.
Very good. So, what advice would you be able to give to future master's students who are working on similar topics to your own?
Well, I would say a lot of research has to be done to start with, right? So if you want to work on a similar topic, especially in this field of explainable AI, which, if you ask me, I would say is the future of artificial intelligence, right? Because now people want to know why we have these errors, for example, or why these results, right? So I would say you need to do a lot of research. If you want to go into this line of project, you need to do a lot of research to start with. You need to really understand why you want to carry out such a project, such a task. So a lot of research has to be put in place, a deep understanding of the inner workings of most of these tools, like the tools in XAI. Like I mentioned earlier, we have a lot of explainable AI tools. So first of all, do research, very important. You cannot take away the importance of research in any project. I mean, project is actually a research work, right? So a lot of research has to be done, and then deep understanding of the inner workings. So reading outside what has been taught in class, making use of all the useful resources that have been put out there for us to use. So research, deep understanding, making use of all the resources available, comparing research work, because one of the things I discovered in my project is we evaluate how good these XAI tools work, especially Radcam, Lime, Sharp, but we didn't really compare which one did better. So something I did in my project, something I think most people also do not pay attention to. So do research, do a lot of comparison, and be patient. And be patient in the entire process. Yeah, there's a lot of challenges, especially when it comes to compatibility of the tools and the models. So there's nothing research cannot do. So research.
Great advice.
Thank you.
Well, thank you for sharing your project with us, Winifred, and congratulations on completing it.
Thank you. Thank you.
Hi, my name is Kevin Pimblett, and I'm the Director of the Centre of Excellence for Data Science, Artificial Intelligence and Modelling, otherwise known as DAME, here at the University of Hull. We run an MSc conversion course in Artificial Intelligence and Data Science here at the University of Hull. A conversion course takes in students from a wide variety of different backgrounds, not just STEM subjects, but arts and humanities and everything else in between. We upskill them in data science and artificial intelligence, and we do that through a series of bespoke modules, starting with Python programming in the first few weeks of trimester, leading into introductory materials in understanding artificial intelligence and the fundamentals of data science. We've just built a new building that you can see all around me. This is a £4.5 million investment by the University of Hull, and a strategic decision to invest in artificial intelligence and data science for the long term. Here at the University of Hull, we offer the full breadth of artificial intelligence and data science. We have elective options in a range of different subjects, from ethics right through to AI in healthcare, and a lot of others in between as well. We like to have our students on campus for one full day per week. That's from 9 AM right through to 6 PM. What this enables is for our students to manage their own time, so that if they have a job for which they might be going part-time, they can do it for the rest of the week, and therefore they can have that full day on campus learning and doing all the programming that they're required to do. There are a variety of reasons why our students choose the University of Hull as their first choice for an MSc conversion course. Not only do we upskill our students within the areas of AI and data science, but also locally this is one of the best regions in which to study. Here at the University of Hull, we offer the widest variety of different training courses in AI and data science. We also offer bursaries that our students are able to apply for, so if you are female, black, disabled, or from a low socioeconomic background, as might be judged from the higher rate of student loan, and you are a UK citizen, resident, or settled status, then please do consider joining us.